Notice your surroundings. Wherever you are sitting right now, your body is telling you a very specific story. You are absolutely stationary. Your coffee isn't sloshing in its cup, there is no wind rushing past your ears, and your feet feel firmly planted on solid ground. Separated from the sun by 1 astronomical unit, or AU, 93 million miles, Earth traces an elliptical orbit. We accelerate to 30,300 meters per second at our closest approach, perihelion, and slow to 29,300 meters per second at our farthest point, aphelion. We are strapped to a rock that is continuously speeding up and slowing down by thousands of meters per second. Yet, because our biology only detects sudden, sharp changes in momentum and completely filters out the smooth, continuous physics of planetary motion, humanity lived for millennia completely convinced that the Earth did not move at all. For 99% of human history, society trusted its physical senses. If the ground didn't feel like it was moving, the logical conclusion was that Earth was the immovable center of the universe, and everything else in the sky simply revolved around us. Early Greek thinkers like Aristarchus actually used geometry to propose a sun-centered model thousands of years ago, but his ideas were entirely rejected. To the people of his time, an orbiting Earth defied basic common sense. You couldn't feel the motion, so it couldn't possibly be true. That illusion held until 1610, when human vision was first artificially enhanced. Using narrow optical tubes outfitted with curved glass, astronomers could finally bypass the limits of the naked eye and observe planetary bodies up close. This geometric visualization illustrates exactly what Galileo Galilei discovered through those lenses. He observed that Venus goes through phases, from a thin crescent to a fully illuminated sphere. That specific pattern of light and shadow is geometrically impossible unless Venus is actively circling the sun. This observational data was highly dangerous to the establishment. It demanded that people stop trusting their own immediate physical sensations, and more importantly, it required them to abandon the literal interpretation of religious texts that placed Earth firmly at the center of creation. The Catholic Church met this astronomical discovery with aggressive institutional pushback. They recognized that accepting a moving Earth meant undermining the authority of the Church itself. Cardinal Robert Bellarmine, one of the top theologians of the time, summarized their defense using a ship analogy. He argued that passengers on a moving ship know they are in motion because they can see the shore receding. But since a person standing on Earth experiences pure stillness and sees the sun moving across the sky, our sensory perception of a stationary Earth must be correct. In 1616, the Inquisition made it official. They formally declared the concept of a stationary sun to be foolish and absurd. Galileo was legally ordered to abandon his Copernican research and was forbidden from teaching or defending the idea that the Earth moved. The breaking point finally arrived in 1632. Galileo published his dialogue, laying out the arguments for a moving Earth. The Church responded immediately. He faced a heresy trial, forced to publicly recant his findings, and sentenced to house arrest for the rest of his life. Galileo's conviction was certainly a suppression of science by a religious authority, but at a deeper level, it was the ultimate tragic victory of human biological perception over observational reality. But silencing one astronomer could not stop the scientific method. As the 17th century progressed, the tools for understanding the cosmos transitioned away from simple visual observation and moved into the realm of rigorous mathematical measurement. Using the method of parallax, astronomers measured Mars from two distant Earth locations, creating a massive triangle in space. Calculating its angles revealed the length of 1 astronomical unit. Plugging this semi-major axis into the orbital velocity equation output the exact fluctuating speeds of Earth. Where human senses failed, and where primitive telescopes could only provide visual hints, the irrefutable laws of physics and mathematics finally provided the hard proof of our motion. The astronomical unit provides the precise mathematical baseline for navigating interplanetary missions and calculating the orbital physics of our entire solar system. As this scaling sequence maps out, the AU also gives us the parsec. By taking the distance of 1 AU and projecting a massive angle of exactly 1 arcsecond into deep space, Astronomers calculate a unit equal to 19 trillion miles. That math is what allows us to measure our distance to other stars and galaxies. Legend says that after his forced recantation, Galileo muttered the phrase, "Eppur si muove," and yet it moves. He knew that despite what the courts ruled, or what our biology tells us, we are permanently strapped to a dynamic, high-speed vehicle. To understand our true place in the universe, cosmos.